During tutorial 4, I picked question 1, which asks if two converging lens a distance of 30 centimeters between each lens, with an object that is 2 squares tall, an object that is 20 distance from the first lens, and the first focal lens length is 10 centimeters away from the lens, while the second focal length is 15 centimeters from the second lens. So first I started by drawing my axes. I drew my x-axis as you can see here. So this one is over here, and I drew a second x-axis that is 30 centimeters apart over here. That's why I have two axes. So I drew the first object, which was 20 centimeters away from the converging lens, which is over here. So I drew it 2 squares high as the question told us to do. And the first line I drew was the line that was perpendicular straight across to the axis and then through the focal length down that way. And my second line was the line that went through the focal length to the axis and then perpendicular across. Next, I drew a line that went through the origin and all the way down from the origin, from the original image. And I drew that line going down this way. And once I had those 3 lines, I found that the image created this met at this point here. And I drew an arrow down to show what the image would look like. And so now I take this image right here that I got and I move it down, just straight down, and I put it over here at the start of my next converging lens. And I don't move the converging lens because we already knew before that they were 30 centimeters apart. I just bring the image straight down. And so I draw this down right here, and then similarly as I did over here, I draw the lines. So my first line was the one that went perpendicular to the origin, so straight across, and then down perpendicular through the focal length. And then I drew a line that went through the origin, so this line right here, across. And then I drew a line that went through the focal length to the axis and then perpendicular out. But unlike the second image, the images didn't intersect, which means in this case we'd have a virtual image because we had to trace the lines backwards, but just 2 of them this time. So the lines I traced backwards were the lines that went through the focal length. So this line right here, I drew dashed lines to show which line I traced backwards. So that one traced that way, as well as the one that went to the focal length on this side. That one went backwards as well. And we met right here, and this was our image. And so now I have the math to show and prove that this was the correct new image right here. So we found that over here that using the lens equation, that 1 plus 1p plus 1q equals 1 over f. And so if we use algebra, we find that q equals p times f all over p minus f. And so when we find that answer, it would be q1, and q1 at the top is 20. And so once you have that image, once you have that new image over here, the q, you take it down here to find the new object distance. And so you would take 30, which was the distance between the lenses, and you would subtract the q1, which is the distance of the image, and you get 30 minus 20 gives you 10. And the focal length is given, and it's 15. And then we do 1 over the lens equation again, so 1 over p plus 1 over q equals 1 over f, using the new numbers we have here. And we put that algebraically again, and we know p times f all over p minus f, and that gives you 30. And it is negative 30, sorry I forgot to say that. It is negative 30 because the image was in the front of the converging lens. And so now we find the magnification, which is just the magnification formula, which is negative Q all over P. And if we know that P is negative 30, so negative 30 times a negative gives you positive 30, so this positive 30 divided by 10 equals 3. So your magnification is simply 3.